Good day, everybody. Brian here from quantlabsnet.com. In this video, I'm going to show you my first ever video on reinforcement learning, anything machine learning. What you're about to see is code-generated or vibe coded, I guess they call it, 100% AI generated for this problem. It did run surprisingly. Um, I don't have the resources like a GPU card in my environment. So I handed this off to somebody else I know that has those resources. So thanks to them for running this. I'll play some of their videos on their environment and we'll go from there. Okay, so let's talk about the files themselves. So these are available on my file share at quantlabsnet.com. You'll have to log in with a Google or Facebook ID to get access to this, but it's free. It's available. What you're going to look for: two files or two zip file, one zip file, trading environment, and the CSV data file. This data file goes all the way back to 1980. Let me just see here. Yeah, so this goes back to 1980. So it's got over 12,000 files, rows. So it's pretty extensive for a back test with reinforcement learning. Again, I'm no expert here, but it's pretty cool. So let me just first show you the two video files. I'm going to first show you the um, running of the results through a Pi notebook. So this is not my uh, computer here. Um, so this is somebody else's environment here as I just load this up. So this is the source code running it in this other person's environment. Signals get generated. There's an agent as well. We'll talk about that in a bit. These are all the mock trading positions. It's all virtual. So there's a lot of them, obviously. It will generate a bunch of signals as well. Um, and I believe there's a P&L as well. But it's pretty extensive. The impressive thing is this is all 100% AI co-generated. It actually runs. Apparently, it took a three-hour simulation to execute this in their environment. I think we'll see in the next video. They're kind of NVIDIA cards. So these are the trading signals right here, um, and that goes all the way back to 2005, as you can see. So it's pretty extensive test simulation. So let's check out the thing running in their environment. Now this is a pretty souped up system or a laptop, and this is their environment here. All the data in the CUDA and then NVIDIA running. So here is the hardware, NVIDIA GeForce RTX, whatever utilization rate at 10% there, CPU, and the GPU running as well. So just wanted to show you that. Okay, so let's go into the source code here and check it out. So this is again the source file. It goes all the way back to 1980 for Apple daily data. So this is now the co-generated source file, Python. So in here, it's beyond impressive. I'm still hearing. I don't know if they're just not with it, that they don't understand the power of AI, what it can do. Depending upon how you generate what you put in the prompt before you run the um, software or the execution, it can generate some pretty powerful source codes that you're about to see. This one is using the following Python packages. So it's going to use TensorFlow. Also going to use Keras. Now, I've not used this a whole lot. And the other thing, it's going to use Gymnasium. Now, I'm going to be honest, I don't know Gymnasium, but my first time seeing this, but it does raise a lot of curiosity out of me. So in here, A couple things if you look at what is also outputted in the file or what can be generated. As I said here, we've got the source file for the Note, which is part of that zip file. Also, here is a what they call an H5 file. So what is that? So it's a hierarchical data format designed to store and organize amounts of data from the National Center of Supercomputing Applications. And I'm going to put this in the links in this blog post. I've also found a viewer of this file, a visual one. So again, I just don't know what these represent, but these are spat out uh, by the GPU. So yeah, you can see all these visualizations, I guess, of this HDF5. All right, so coming back to the source code, that's one level of using uh, for machine learning with the Keras. Also, you can see here we have the gymnasium. So there was originally OpenAI Gym, and then there's a gymnasium package. So if you look at this is from OpenAI, and basically what it is something to do with agents. It provides an API for all single agent reinforcement environment implementation of common environments, cat pool, pendulum, mountain car, and so on. The core, high-level Python class representing a Markov decision process from reinforced learning theory. So again, this is going over my head, but just to show you what you could generate with this AI now. This is not a perfect reconstruction, missing several components of MDPs. Class provides user ability to generate initial state, transition, move to new states given an action, and visualize the environment, and so on. So if you look in the source code here, um, we set up an environment, but this is specifically for trading. So we have an initial balance of 10,000, a window size of 20, a number of past days to consider as state, with a commission rate 1% or 0.1%, trade size, available balance to use for by trade, and then we get into the RL, reinforcement learning agent hyperparameters. So this is again fairly advanced, but this is specific for trading. So here it looks like we have action, size, buy, hold, and sell, and then it goes into a learning situation here. So we have a gamma, epsilon, and batch size and whatnot. So all of this is plugged into his environment for the GPU, and it took 3 hours to run this. So you can see here we have open percent change, high percent change, low percent change, and closed percent change with the price history. Uh, I'm still trying to decipher this myself. So data frame gets generated. Then we have a holding stock flag, and I guess right here, self-held current price for normalization, price history, current step, normalized entry price as well, additional features, observation, and it does quite a bit of things here where it takes action, where I believe this will, I'm not sure, assures to buy float. And this is very advanced quantity mathematical models that have been used for this. Um, and we have a sell condition, action, and then we have the hold. So the prior one was the buy. Um, and then we have a reset here. We have our net worth, balance, share held, and so on and so forth. Okay, I'll let you just play with it. Here's the interesting part now. This is the first time there's an actual agent involved. Okay, and again, hand code this we don't do anymore. I guess we use some form of AI to generate it. Again, I'll let this be self-commenting. And here's, I guess, a map that you provide, and then the columns based around the data frame. And oh man, this is like way over my head. So it does its training, 100 episodes, that's defaults to. Um, Goes through the looping of it with an agent involved. And we have training finished, final model saved with the weighting in that H5 file. Uh, so we have our plotting the results into the final net worth over training, uh, agent loss training step as well. So we get our trading results, running evaluation of the agent, evaluation, final net worth, number of trades in the evaluation, agent net worth, agent performance, time steps net worth. So it gets fairly advanced here, as you can tell, running it with this level of reinforcement learning and an agent running at the same time. Could not calculate buy and hold. So these are buy and hold trades, I believe. And yeah, this is pretty wild stuff. So I'll let you go through that. Now, as I said, this is way over my head, but with AI, for me, somebody like me, it's very enables you to quickly learn and reverse engineer with this type of code. I'm just providing this for free just to show you two things. A demonstration of an AI agent with reinforcement learning on top of how you can code generate it with a potential problem or even now a mathematical quant um, scenario, run it because you're able to generate the code from it, run the simulation, see what the results. I mean, this is the amazing world we live in. Anyways, we'll leave it at that. Now, if you want to learn more as I progress with this, you can go over to quantlabsnet.com, put in your information for a free HFT book with C++ also. I'm doing this in Python because it's easier. That's what people want. It's easier to maintain. To build this in C++, it's really difficult. I think you only involve C++ when you get into a live production trading environment with real money to make it a lot faster. But we're getting there. And this is 100% done in Python, as I said. So you can join here on learning about this stuff. Anyways, thanks for watching, and a big thanks to the person donating their environment, running the simulation as well. It's pretty impressive, and we'll leave it at that. Thanks for watching.